So today we're going to start with the Dream Web Framework. So let me go to the website. Let me paste the link in the chat. So this is written in OCaml. It's a very tidy, complete framework as mentioned, which you can use to write web applications. It supports TLS, WebSockets, GraphQL, and it's quite easy to use. You have templating, router, session management, error handling, all the goodies that you can see in a web framework. The important thing is it is written in OCaml and is composable, very nice to use. So what I want to do is go over the tutorial, and we'll try some examples here, and then later on you can also explore writing your applications using this Dream Web Framework. At this point I also want to mention the recent and OCaml Bangalore meetup. This is organized by Manas, and this is scheduled on Sundays at 2 o'clock in the afternoon. So he also does a lot of web development with Reason ML, which I would encourage you to attend and learn from this meetup as well. We're also starting a Chennai OCaml meetup at the Teradus India office. The first meetup is scheduled to begin on June 7th, Friday, between 5:30 to 7:30 Indian Standard Time. So do RSVP if you are interested to participate in these meetups. So with that, I want to talk about why we are focusing on Dream Web Framework here, and why you should be writing applications using this. This is a demo video of the Mirage website, which is the Mirage OS HTML pages, which are served on a Raspberry Pi. Okay, so this website, entire website, is served from Raspberry Pi, and Mirage OS is a framework to build type-safe modular systems. Okay, so in this demo, the leftmost two windows show logging into the Raspberry Pi. Then I run the Mirage unikernel hosting the documents, and then on the right side you have the browser where I connect to the server, and you can see the same rendering of the HTML page. There's no audio here, so I'll just give you commentary on this demo. So this is the logging in session into the Raspberry Pi with IP address 1.17. I'm also logging into the Raspberry Pi at the bottom window to run htop, so you can see the processes and memory consumption. And then I run the www documentation on a SoloFi kernel, which is a unikernel. And once I start the web server with the unikernel, I go to the browser and I hit refresh. It basically returns the results of the web page running on the Raspberry Pi. Now the important thing here is, if you look at the memory consumption on the unikernel, it is only 29 megabytes. Okay, so today we are talking a lot about CPU computing power, power consumption, energy saving, and so on. So it's very important that you also monitor these things. So using the Dream Web Framework, which is written in OCaml, it will be good to run all of these applications in some of these unikernels, so that it's quite type safe, memory efficient, and also fast. So that's the context where this session and future sessions on writing web applications is going to be. We will try to explore all of these topics, but before that, let's go through the tutorial. So the link to the Dream Web Framework, let me paste it in the chat as well. So we do have a list of tutorials, and the links are there in the README. Okay, I've pasted it in the chat, and we'll go through all of these tutorials. So let's start with the first one. Before that, let's clone this repo. So the Dream framework has these examples in an example folder. So if you go to the home page, click, you can actually clone this repo. Okay. And I am currently on OPAM 511. Okay, and there's a link to quick start. So basically you need to have OPAM installed, you need to have a switch at least 510. So evaluation of the environment is done. Dream is actually installed already on my environment. So I basically completed all of these steps, but I encourage you to try this. Please go through the OCaml documentation series where I tell you how to install OPAM and the switch and so on. Okay. Now with that, let's start with the tutorial. So there are many examples given here. The first one is the hello world example. It basically sends a response. Then we'll go through the Dream middleware example with the logger. Then we'll look at handling routing and having different paths. Okay. So if we go to the Dream GitHub repository, there are multiple files here, and in the example folder we have all these example code. So the first one is 1-hello. Okay, let's first go to the files. Let's look at hello.opam. So here they're saying OPAM version 2.0, depends on OCaml greater than 408, Dream, and of course Dune, which is the build system. Let's look at Dune file. So we're creating executable name hello, and the library we're using is Dream. Then we have Dune project, specifying language Dune as 2.0, and then we have the hello.ml file. So let dream.run function, we call dream.html with good morning world. So this is a minimal Dream server. It responds to all requests with the same text. At startup, Dream prints a message to the log telling you where you have to point to your browser. Okay. Of course, first we have to make sure we have all the dependencies installed. So you can do opam install deps only yes dot. There are some errors and warnings in the OPAM file. I think it will be good if you can try and create a pull request to fix these. So this ensures that the necessary dependencies are available in the environment. and then we can execute the hello.exe file once it's done, and then it should run the server on port 8080, and then in the bottom terminal I'll mostly run curl to demonstrate the get requests. Okay, so just wait for op-amp install to finish. Now we can start the server hello.exe. It compiles the file, it starts the server on localhost 8080. I can just do curl localhost 8080, and that returns our message, good morning, hello world. Okay. So if you like to copy this binary out, you can just copy it from the build default directory. Let me stop this. There you have the hello.exe file. Right, so let's next move on to the second example, which is middleware, so which is there in the 2-middleware folder. So middleware is just functions that take handlers and wrap them, producing bigger handles that do a little more functionality. So we are going to build on top of the hello example, and we're going to wrap it in a logger middleware. Okay, this is the code here. Let's look at the files here. So we have middleware.opamp, it is similar to the first example. Then we have Dune, and we have Dune project. So here the executable is called middleware.exe. We're still using library dream, and then we will see the file. So we're just wrapping it in the dream.logger middleware, and the same text is going to be returned. So this is one way of writing it using parentheses. To keep the code tidy, the standard OCaml operator for calling functions without parentheses is used. This is the code. So let's try to run this server here. So again, I'm going to make sure I have all the dependencies installed. Yeah, again we're seeing those errors and warnings, so I think it'd be good to fix those checks in the sources by creating a pull request for the same. And once this is done, we will run the middleware.exe from the build default directory. Now one new change that we should see when we execute this is the dream.log handler, right? It should print the request messages. It is quite useful for debugging, for example. Yeah, middlewares are just functions from handlers to handlers, so you can create them anywhere. So this is done. So now let's run this using --root /middleware. Dune exec --root middleware.exe. Okay. So now if I again make the same request, we see that dream.log is printing those requests in the log, right? I can do one more request and it'll keep printing it. Okay, so that's the middleware functionality that is useful for debugging. Let's move on to the third example, which is router, or how to do routing. So a router sends requests to different handlers depending on the method and path. So in this example, we are still going to serve the good morning at our root site, but we are going to have a different response for get request to /echo/star, and for everything else we respond with 404 not found. Okay. Same dream logger, we add dream.router here, adding two routes here. In dream.get with the root will return the good morning world, and then dream.get with /echo/word we are going to return the word itself. Okay. So let's compile this first, make sure we have the dependencies installed before we can compile the executables. So again, this is our first dynamic site, right? So a request to /echo/foo should return foo, and similarly a request to /echo/bar should return bar. Okay. So the syntax :word in the route, it creates a path parameter, okay, which can be read from dream.param. Because if none of the routes match, it will return a 404 not found. So again, this source file also has these warnings and errors that need to be fixed. It will be a good first issue or help wanted PR that you can create for the dream project. Again, similar files, 3 router opam dune. Here we are calling the executable as a router, and the library we are using is dream. Dune project is same, and then we have router.ml, which is what we've seen in the tutorial browser section. So let's run this dune exec -root./router.exe. Okay. Now I'm going to hit the default route, it returns the same thing. Now if I do /echo/foo, returns foo, /echo/bar, it returns bar. So still see the logging happening in the background. If I do something does not exist, basically here it returns a 404 we see in the log. Okay. So let's stop here. This is a very short tutorial on cloning the dream project, making sure you install the dependencies. I would suggest you go through the opam setup video in my playlist. If you have not already set up the opam switch, it should be this one, in 11th one, right? This is the one you need to install opam and create opam switches. About 39 minute video. So watch that and then make sure you install the dependencies, and feel free to let me know if you have any issues in trying these tutorials. With that, let me stop the recording and